Hey guys, Mr. Backberg here. In this video, we're going to look at solving trigonometric equations. So as we're taking a look at this first equation, we are going to solve the equation sine of 2x equals the cosine of x on the interval from 0 to 2 pi. Now because I see that sine of 2x in there, we're going to use a double angle identity to help us out. So the sine of 2x can be replaced with 2 sine of x cosine of x equals the cosine of x. Now we don't typically like to solve an equation with variables on both sides, so I'm going to subtract this cosine of x over to the left-hand side. So you would get 2 sine of x cosine of x minus this cosine of x equals 0. Now I notice that both of my terms have the cosine of x in it, so we're going to take that out as a GCF. So then we'd be left with 2 sine of x minus 1 equals 0. And now that we have this factored, we're going to take each individual factor and set it equal to 0. So we take the cosine of x and set that equal to 0. And then we take the 2 sine of x minus 1 and we set that equal to 0. Now this first piece is ready to solve. We're going to look on our unit circle. Remember, cosine is the x value from the ordered pair, so we're looking for an x value of 0. So that happens at the angles pi over 2 and 3 pi over 2. Now, because we're told to stay on the interval from 0 to 2 pi, we don't have to worry about coterminal angles with these, so that's our first set of answers. Now, the second piece is going to take a little extra solving because we want to get this sine of x alone. So the first thing I'm going to do is add that 1 over to the right-hand side. So we would get 2 sine of x equals 1. Then I'm going to divide that 2 over to the right-hand side, so we get the sine of x equals 1/2. Now, as we're taking a look at the unit circle, remember sine is the y value from the ordered pair, so we're looking for y values of 1/2, and that happens at 2 places on the unit circle. That happens at pi over 6 and also at 5 pi over 6. And again, because we're told to stay on the interval from 0 to 2 pi, we don't have to worry about any coterminal angles. So our answers are pi over 2 and 3 pi over 2, but also pi over 6 and 5 pi over 6. In this example, we're going to look at solving the equation sine squared of x equals 2 sine squared of x over 2. Because I see that x over 2 on the right-hand side, the first thing I think about is using one of my half-angle identities. So we're going to get the sine squared of x equals 2. Now, normally our half-angle identity has a square root on it, and this would be 1 minus the cosine of x over 2. But because this sine is squared, we need a squared power on that, and that's actually going to cancel out with this square root. So then what we're going to have is the sine squared of x equals 2 times 1 minus the cosine of x over 2. Now this times 2 and this divided by 2 are also going to cancel each other out. So now we've got ourselves the sine squared of x equals 1 minus the cosine of x. Now we've got two different trig functions in here, but we can actually get this to be just one trig function using a Pythagorean identity with that sine squared on the left-hand side. So sine squared of x is 1 minus cosine squared of x, and that equals 1 minus the cosine of x. Now if we subtract this 1 over to the left-hand side, those 1's are actually going to cancel each other out. And then I'm going to add this cosine of x over to the left-hand side. So we get cosine of x minus cosine squared of x equals 0. Now each one of these has a cosine in it, so we can factor out the cosine of x to get 1 minus the cosine of x equals 0. Now that we've got this factored out, we're going to take each factor and set it equal to 0. So the cosine of x equals 0, and 1 minus the cosine of x equals 0. This first part's ready to solve. Remember, on the unit circle, cosine is the x value. So if we're looking for x values of 0, that happens at the angles pi over 2 and also 3 pi over 2. Now on this one, we're not told to stay on the interval from 0 to 2 pi, so we do want to account for all of our coterminal angles. And looking at what we've got in this function, we're going to have a period of 2 pi. So this is going to be pi over 2 plus 2 pi n, and this is going to be 3 pi over 2 plus 2 pi n. And over here, we need to do a little bit more solving. I'm actually going to add that cosine over to the right-hand side, so we get 1 equals the cosine of x. We're still looking at x values on the unit circle, and the one place where we've got a cosine value, an x value of 1, is at the angle 0. Now if I take 0 and add 2 pi n to that, I don't really need to put the 0 plus in the front, so we can just think about that as 2 pi n. So my answers are going to be that pi over 2 plus 2 pi n, that 3 pi over 2 plus 2 pi n, and then we can either think about it as 0 plus 2 pi n or just 2 pi n. That's going to be it for this video. Thanks for watching.